The myth I tested was that of all the flavors of ice cream, chocolate ice cream melts the fastest if two flavors are subjected to the same conditions. This is believed to be true because chocolate ice cream absorbs more light because of its dark color and thus more energy, causing it to melt faster than other types like vanilla, which reflects more light than it absorbs. First, I labeled each cup with the different flavor I would be testing with. To test the myth, I took the labeled cups and then placed a wire mesh above each of them. Although there are dozens of flavors of ice cream, I chose only 6 for this experiment. The 6 flavors I tested were chocolate, strawberry, vanilla, Java chunk, waffle cone, and raspberry. For this experiment, the initial testing temperature of the ice cream was -2 degrees Fahrenheit, and it was subjected to both light and a room temperature of 63 degrees Fahrenheit. After adding roughly 3 tablespoons of ice cream to each cup, this is what the final setup looked like. To test the myth, I recorded the time it took for each flavor to fully melt or for no solid ice cream to be left on top of the mesh. I took pictures of the melting every 15 or so minutes. At 15 minutes, there wasn't much melting occurring yet, and there were only a few drops at the bottom of each container, but one could see that Java chunk was currently melting the fastest. At 30 minutes, one observes that chocolate had melted the most, followed by Java chunk and then raspberry. Waffle cone, vanilla, and strawberry hadn't melted much because of their light color, meaning that they reflected most of the light. By 45 minutes, the chocolate ice cream had fully melted, and in reality it only took about 40 minutes. The raspberry ice cream was close behind, along with the Java chunk and the waffle cone, which had melted quite substantially during this time period. Vanilla and strawberry still hadn't melted that much. By 53 minutes, the raspberry ice cream had fully melted, as shown in the video, and the vanilla ice cream was close behind. The strawberry ice cream had melted at 60 minutes, but since the vanilla ice cream had caught up to the waffle cone and the Java chunk in terms of how much ice cream had melted, it seems that the ice cream melting rate is not consistent. Otherwise, the waffle cone or the Java chunk would have already melted. In the end, the vanilla actually ended up melting faster than both the waffle cone and the Java chunk. So vanilla ended up melting at 67 minutes, waffle cone ended up melting at 82, and Java chunk ended up melting at 78 minutes. Based on the results, the myth is confirmed because chocolate ice cream melted the fastest. One can compare this to the Java chunk ice cream, which had a similar color and therefore similar absorbance of light as chocolate. And since the Java chunk didn't melt at the same rate as the chocolate and actually took longer, the myth is confirmed, because if two ice creams are subjected to the same conditions, the chocolate ice cream will melt faster, and this was also confirmed with 4 other types of ice cream. I wasn't thoroughly convinced, so I decided to continue testing. The only difference with the second experiment was that the ice cream was not exposed to any light, and the goal of this was to see if 2 ice creams were not exposed to light and one of those ice creams were chocolate, would the chocolate still melt the fastest? After placing my ice cream in the box, I then sealed the box, and then proceeded to open the box to record pictures every 15 minutes. In this experiment, each type of ice cream actually took quite longer to melt when compared to the first experiment when each trial was exposed to light. In this experiment, raspberry actually ended up melting the fastest at 62 minutes, then followed by strawberry at 67 minutes, and then chocolate at 75. And then vanilla and Java chunk both finished roughly around 80 minutes, followed by waffle cone at an hour and a half. So this shows that light clearly had a significant impact on the melting rates of the ice cream, and specifically with chocolate. Because these trials were tested in the absence of light, the ice cream didn't absorb as much light, and therefore didn't absorb as much energy, so therefore they each took longer to melt. Since chocolate had a darker color, it wasn't able to take advantage of that with the light because there was no light, and therefore took longer to melt. So the ice creams ended up melting based upon their consistency. One thing I forgot to take into account that definitely impacted the time it took for each ice cream to melt was that the ice cream inside the box caused the temperature inside the box to decrease below the room temperature. I had figured that since air was escaping from the box, that the temperature inside the box would equal the room temperature. However, this was not the case, and I'm not sure the extent of the impact of this on the amount that melted. Obviously, it caused the amount to melt to decrease. However, I'm not sure the different. I'm not really sure of how this was different from the impact of the absence of light on the amount of ice cream that melted. So we have to go back to our original myth. If there are two types of ice cream, and one of the types of ice cream are chocolate, and they're both subjected to the same conditions, the chocolate ice cream will melt first because the chocolate has a darker color and therefore will absorb more light and therefore more energy and therefore melt faster. So based upon the first experiment, that was proven to be true, so we can confirm the myth. And the second experiment shows that light was the reason why the ice cream melts faster, because without light, or in the absence of light, the chocolate ice cream does not melt as fast as other ice creams such as raspberry or vanilla, so given this, one can confirm the overall myth. Thank you for watching.